Okay, so this video module is going to discuss t-tests. Again, I need to mention that the creators of this video are not associated with any particular program, course, or instructor. This video was designed with general knowledge purposes in mind only, and if you see any mistakes or have any questions about content in the video, please let us know, and we'll be happy to make corrections if that should be the case. So look at as an overview of the t-tests, also called student's t-test after the pen name of the creator. T-tests determine the significance of the difference between means, especially population means, of two groups. In other words, we are interested in how the real mean and standard deviation differs from the observed or perceived mean and standard deviation, as we might have seen from a study or some kind of data, database we might have gathered. So before we perform the test, we are going to have to establish our null and alternative hypotheses. So these hypotheses are going to allow us to place our p-value into context so we can better understand the result of the test. If we fail to set clear a priori hypotheses, we will not know at the end of the test whether a significant value means a difference between two groups or if a significant value means that there is no difference between two groups. So setting out your hypotheses clearly for each test is going to serve to remind you exactly what that p-value means. So for a t-test, our null hypothesis is that there is no difference between the two groups, whereas the alternative hypothesis is that there is a difference between the two groups. So if we get a significant p-value and we reject the null hypothesis, we are going to conclude that there is a difference between the two groups. So now that we have our hypotheses, we can begin to perform the test. As with most statistical tests, t-tests can be performed either by hand or on a computer using various statistical software. And it's important to be familiar with both methods in order to properly understand the test and how it works. So when we're first interested in starting a t-test, we have a couple options about where we want to begin. There are three different types of t-tests depending on the kind of data you are working with and the conclusions you hope to draw. So the first one we can look at is a one-sample t-test, which compares the mean of your sample to the mean of a known population. For example, you may wish to compare the IQ of McMaster Health Sciences students to the IQ of the general population. So if we know that the mean IQ for the general population is 100, we can use a one-sample t-test to determine whether the IQ of McMaster students differs from the general population. It's important to note that this one-sample t-test is not the same as a one-sided t-test. Those are two different things, and we will not be discussing one-sided t-tests in this video. The next test we can look at is an independent samples t-test, which compares two sample means in the hopes of seeing whether the population means differ between the two groups. Finally, we can look at a paired samples t-test, which is used when matched pairs are present, such as the two blood pressure readings from the same person at different times perhaps, or data points especially received from twins. So paired samples are not independent of each other, whereas independent samples data points are independent of each other. So after we've decided which test we're going to do, we can input our data into SPSS, and we can decide which particular test we want to run. So we can select a one-sample t-test, independent samples t-test, or paired samples t-test. We will be asked to input a test value or the population mean for comparison. In the t-test, we are going to be asked to define the two groups we are going to use for comparison. And if we select a paired samples t-test, we are going to be asked to input or select the paired variables of interest to us. We can also perform t-tests in Excel using the free statistical add-ins available in almost all versions I'm familiar with, and the output that you will get from such a test is very similar to that of SPSS, so we won't be discussing it any further. So this is the formula for one sample t-test. In this formula, x bar is going to represent your sample mean, mu is going to represent your population mean, S is the sample standard deviation, so derived from the same sample as x bar, and n refers to the number of individuals in your sample size. Using this formula is going to give you a test statistic, which is not equivalent to the p-value. So this t here will need to be looked up on a table to determine your p-value. This formula will not give you your p-value directly. This now is a formula for an independent sample t-test, so we can see it's very similar to the previous formula, which was for the one sample t-test. The only exception here is that we've added a second group for comparison, so a second x-bar, a second standard deviation, and a second sample size. Finally, we can see our formula for the paired t-test. It's important to note that this x-bar and sample standard deviation is now referring to the difference between pairs rather than the actual numbers that the pairs represent. Other than that, that's really the only difference we need to be concerned with here. So this is a sample output from SPSS. We can see the first section, I guess, is Levene's test for equality of variances. This is going to tell us whether equal variances can be assumed, which is one of the assumptions for t-test. Now SPSS will calculate the t-value either way, just making some additional corrections if perhaps equal variances cannot be assumed. Since we see that the significance of Levene's test is non-significant, we can safely assume that equal variances are present and continue with our t-test. We can see here the test statistic has been calculated, our degrees of freedom, and we see here our p-value, which is under the significance two-tailed region. So this would be a two-tailed t-test which was conducted. And we can see here that by almost all accounts, this is a non-significant p-value because it's much greater than that alpha of 0.05, which most people tend to assume. So we can safely conclude that we are going to fail to reject our null hypothesis and conclude that there's no difference between the two groups used in this particular t-test. Or the take-home message is that there are three kinds of t-tests. One sample t-test, independent sample t-test, and paired sample t-test, and these can be used to compare one sample mean to another mean.